Demand planning in the oil and gas industry presents unique challenges due to the influence of macroeconomic factors, seasonality, and even geopolitical events on consumption patterns. SAP IBP for Demand provides the tools to address these challenges by creating robust statistical forecasts and allowing collaborative refinement of the demand plan. IBP comes with a rich library of forecasting models and algorithms, from simple time series models, moving average, exponential smoothing, to advanced ones, Croston for intermittent demand, machine learning regression, ARIMA, and so on. Planners can leverage IBP's automation and AI-driven insights to improve forecast accuracy. In the context of oil and gas, different demand streams may require different models. Refined fuels, gasoline, diesel, jet fuel, usually have seasonal patterns. For example, gasoline demand peaks in summer driving season. IBP can automatically detect seasonal patterns and trends and choose the best fit model for each product location combination. Heating oil or natural gas demand is weather sensitive. IBP's models can include external indicators, so planners might include temperature forecast or HDD, heating degree days, as an explanatory variable in a regression model to predict heating fuel demand. Petrochemical feedstocks might correlate with industrial output or GDP. IBP allows incorporating such macro indicators into the forecast equation if needed. Lubricants or specialty products might have more stable or slow-moving demand. IBP can apply Croston's method for intermittent demand in such cases. One of the advantages IBP brings is the ability to classify products by demand pattern, trend, seasonal, sporadic, and so on, and automatically apply appropriate algorithm. The system can also generate accuracy metrics like MAPE and bias for each forecast and suggest model improvements. Oil and gas companies, especially on the downstream side, fuel distribution, benefit from short-term demand sensing. For example, IBP's demand sensing can use the most recent daily or weekly sales data to adjust the near-term forecast. If a sudden spike in fuel purchases is detected, perhaps due to an approaching hurricane causing panic buying of gasoline, the system can sense this and adjust the forecast for the next few weeks upward to ensure resupply is planned. This helps reduce the bullwhip effect and avoid stockouts in the very short term. IBP's advanced demand sensing refines short-term forecasts to drive better fulfillment and inventory management, which is highly valuable when unforeseen events, weather events, sudden economic changes, rapidly change consumption occurs. IBP allows multiple stakeholders to contribute to the demand plan. In oil and gas, the demand plan may not be the result of a single statistical forecast, but rather a consensus between various inputs. Let us consider these inputs. A statistical baseline generated by IBP as described above, adjustments from the sales marketing teams who might add market intelligence, for example, expecting a spike in diesel demand because a competitor refinery is down, or anticipating reduced jet fuel demand due to travel restrictions. Input from trading or commercial teams who might have insights on customer commitments or export market opportunities. Sometimes even customers or distributors might provide forecasts. For example, a national petroleum distributor might share their expected orders. IBP can incorporate such collaborative inputs via its Excel interface or web UI, where each stakeholder can input their numbers or override and document assumptions. A typical process is that IBP produces a statistical forecast at a granular level, say daily or weekly, by product, by depot, which is then reviewed and adjusted by regional planners and aggregated for an S&OP demand review. During review, planners use IBP's visualization and analytics to compare the new forecast with last month's plan or with budget targets and identify any large deviations. Any changes, for instance, a big upward adjustment for gasoline in one region due to an upcoming holiday travel season, can be made directly in the IBP Excel template, and the changes are visible to all in real time, maintaining a single version of truth. While oil and gas might not launch new products as frequently as consumer goods, there are cases like introducing new fuel formulations, for example, a new biofuel blend, or opening new markets. IBP supports product life cycle modeling. One can use a like model approach where a new product's forecast can be based on a similar product's history, or phase in phase out curves can be applied when switching grades or replacing a product. This is useful for planning transitions such as new fuel regulations. For example, moving to ultra low sulfur diesel, planners can phase out old diesel demand and phase in the new grade in forecasts. Another aspect is that IBP demand plan can be integrated back to execution systems for distribution planning. For example, if the IBP forecast for gasoline for next month in a region is X barrels, this can inform distribution scheduling systems or be input to TSW, Traders and Schedulers Workbench in SAP ISOL, to begin planning shipments. There are SAP provided integration scenarios to pass IBP demand plans to S/4HANA oil and gas solutions, ensuring the downstream systems like fuel supply scheduling are aligned with the latest demand outlook. Consider a national oil company that supplies jet fuel to multiple airports, gasoline, diesel to retail stations, and natural gas to power plants. They use IBP demand to forecast each of these. For jet fuel, they incorporate data from airlines and airport traffic projections. IBP's forecast picks up seasonal patterns, summer travel versus winter lull, and also includes a special event, for example, a major sports event in the city as a one-time uplift. For retail fuels, they use daily point-of-sale data from gas stations for demand sensing. IBP detects a slight upward trend in gasoline sales over the last 2 weeks and revises the short-term forecast up by 5%, preventing a shortfall. For natural gas, they bring in a third-party weather forecast feed. A colder than average winter outlook causes the statistical forecast to increase expected gas demand for heating by, say, 8% for Jan-Feb. Planners review this and confirm the adjustment. During the demand review meeting, they notice overall demand is 3% above the previous plan. They annotate IBP with reasons colder winter, economic uptick to inform the supply planners. This collaborative, data-driven approach yields a much more reliable demand plan than the old method of gut feel or simplistic growth rates, thus giving the supply side a solid foundation. In conclusion, IBP demand planning helps oil and gas companies better anticipate market needs. By using powerful algorithms and real-time data, it improves forecast accuracy and responsiveness, which is vital to avoid issues like fuel shortages or excess costly inventory. It aligns all stakeholders on the expected demand, forming the first step of the integrated business plan. With the demand picture in hand, the next challenge is to plan supply to meet this demand, which we address in the following sections on supply, distribution, and inventory planning.